Right, we're going to do a featured repair video perhaps every day until we've covered every single model number of the repairs we get in. This has come in with the complaint that when they're plugged in there's a crackling noise. Now crackling generally means mains electricity is crackling, and that can be due to a damaged cable, damaged socket, that sort of thing. And we inspect them when they come in. So we have, there's a crack in the plastic, and this is why we inspect them. You see the tip there? That plastic is broken and it's a bit raised up, so when we touch these we're going to have to be very careful not to make that worse. We may be able to just melt the plastic on the back, on the inside, just to stop that from coming out, but if that would come off, then a new arm might be required because hair can catch on that. So this is going to be an interesting repair. So yeah, we'll see what we can do with that. But this model is a 4.2. It is a Type 2 because it's got these little rows of elongated dots. It would be a Type 1 if it just had the slots in there without the dots. They're well used, they're faded, a little bit dirty, and looking at the ceramic plates I can see a couple of little scratches and marks, but I've certainly seen worse. The hinge caps are present, but they are worn. This cable feels a bit not good. It's the original cable. We would always check it for any damage, and in this case you can immediately find some unacceptable damage. That would be a pat test fail. Obviously you can see right the way through to the inner coloured insulation. Yeah, we'll be definitely fitting a new cable to this pair. This has a adapter on the end. The GHD cables used to come with a 2-pin Euro plug with the adapter. That was very handy if you wanted to use them in Europe. You could just take off your adapter and plug them straight in. But GHD cheaped out, and now they fit moulded plugs to everything, so wherever you go you're going to need an adapter for that part of the world. So first thing we're going to do is just carefully prise off these hinge caps. This is just a flat tool for phone, repairing phones, that sort of thing. But we can just gently slot it under there. Very often these little plastic tabs will break, and you would have to super glue this back in place. But again, it's not a particular problem. There are 2 screws, so I have a drill bit, not screw bit, stuck in the work surface here. You can't see it, and then I've just used an electric drill, rechargeable drill. In this case it's too tight, so just over on the side here I have another one of these bits, again embedded into the work surface. It's just off camera unfortunately. Let me see if I can turn that around. Yeah, and then I will use an impact driver, not as it's intended. I'm just using the weight of it to crack that joint open. Occasionally we have to get the hammer out and use the impact driver as it's actually intended, but more often than not we can just use its weight to crack that joint open. So now we've got a hinge pin to just poke out, which we'll do with the screwdriver. And in this case we have what we call a Type 2 cable and socket. It was always an absolute rubbish design and very prone to sparking and arcing and causing all sorts of problems. So in this case we'll be taking the cable cover off, and that is the socket that I'm talking about, and you might not be able to see in there, but that is all sooty and burnt, and that's where that crackling noise is coming from. Now the cables go to the local scrapyard, and they like to have the plugs separate, so everything here is ends up being recycled, which is good. Now we've got to change this socket, and we will be changing it to the newer type, what we call a Type 3 version. It's super reliable, as is the Type 3 cable that we change this to. A couple of screws, just holding the wires in place. We film, I say we, I film every repair that I do, just for record keeping, or very occasionally a customer will complain that they got their irons back and they were scratched or something. We find that people can be very critical when they get things back and they really haven't looked at the irons for years. So we film and comment on any scratches and marks, and for instance that damage on the tip there, which we'll have a little look at in a minute. Not sure I can do anything about it, but we'll certainly have a look. Using a little Dremel tool to remove a little bit of the plastic from this new cable. The manufacturer's just slightly oversized the cable end during the last batch of manufacturing, so on these older irons we just take a tiny little bit of the plastic off so the cable pivots freely and isn't too tight. I actually have a little test jig here that we pop the cable into and just make sure it is absolutely fine. Oops. Yeah, see, spinning perfectly freely, so I know that that is going to fit perfectly. Now we will pop a little bit of contact grease onto the metal and just a little bit onto the plastic swivel part of the joint. We just want to make sure that these spin nice and freely without any issues, no sparking, nothing. As I say, the Type 3 cable and socket is very, very reliable. Very rarely have to change a Type 3 socket, unlike the Type 2 that was originally fitted to this pair. So that is it as far as the cable is concerned. We also inspect this plug adapter. We make sure it's got the correct fuse in there and this isn't broken. The plastic pin is okay, everything looks fine. In this case it's got a 5 amp fuse. 3 or 5 is absolutely fine, 13 amp is absolutely not fine. You do not want a fault developing and 13 amps being able to flow through something like this. Okay, so we're going to take the multimeter now, and it's on, in my case, a 200 ohm range, and we're just going to check the contacts of the thermal fuse. Thermal fuse is good. You get a very, very low ohms reading. If it's okay, it'll be generally open circuit. If it's failed, although it can read a higher resistance than normal if it's partially failed. So now we're looking at the elements, and we're expecting around a 30 to 35 ohm reading, which is good. Silicon is in the correct place, not missing, as we often find when previous repairers have got into a pair of irons. They sadly frequently leave out these crucial little safety pieces like the silicon rubber pieces here that you might be able to see. What I've done here is I've just taken the mains switcher top off. I'm just going to gently tap I'm tapping my hand on the bench, and those little metal fingers will fall out. I'm now cleaning the fixed contacts inside the main switch. They're a little bit burnt, there's some soot that's built up over the years, so we just clean these back to the bare metal. And same with these two little fingers, I just wipe over them, clear off the loose soot, and then I would just gently use a flat blade screwdriver just to rub off the embedded soot and pop that back in. Same with this one, wipe off the loose soot that is pretty much stuck on the grease and just gently clean those. Now they obviously have to go in the correct way, so we just spin them around and make sure they're all lined up. We pop the top on, check it's okay, put the switch cover back on, and in this case we're just going to have a quick peek at this end. Yeah, that's broken. I don't know whether that's happened in the post or... Now what we're going to try and do here is just burn the plastic underneath and just melt that enough to stop it from coming loose anymore. There, that's on the inside, you can't see that. This sort of plastic is not really mendable, you can't do much with it, especially due to the high temperatures, 185 degrees, 186 on the ceramic plates. It's not helpful when you're trying to repair that sort of thing. So we will just put this cover back on. Just make sure the ceramic element moves around freely, which it does. Now we'll spin these over onto the other side and we'll have a closer look. When there's sparking going on, there's two resistors here that can fail. Either one of them can fail. They're in series, so it's a weak spot on all of the 4s, 5s and earlier models. So we will check on the 200 ohm range each one of these. We actually change both resistors whatever, but it's just nice sometimes just to check them. When they've failed, you will generally see a burn mark in one of them. It's unusual for both to fail together, but it can happen. We've got desoldering tweezers here. You can obviously use a soldering iron, but we will just lift off one at a time. Interestingly, this is a point where most other repairers start trying to save a few pence, and they will either not change them routinely, or they will just change the single resistor that's failed. We do not go with that approach, because it means at some point those resistors will fail and the poor customer is going to be sending these back for another probably chargeable repair. So we change these resistors on every single pair that come in, whether one has failed or not, because we know it's a weak spot, and if we don't change them, the customer is going to have to pay for another repair in the future, and we just don't believe that that's correct. So right, so that's pretty much it this side. Based on the symptoms, there really is nothing else to be concerned about. Again, so whilst we've got these apart, we are looking for any issues, like missing silicone rubber pieces and scratches and cracks, and just commenting on them as we go. So in this case, we are now just going to reassemble this hinge spring, and I get asked often about which way this spring goes back. There is a longer tab here. Hopefully you can see that longer section, and that literally goes down towards the switch and forwards, and you just pop that in, and then you get your nylon bush, and that just slides in. Just line the holes up and then put the arm together, squeeze the hinge together under the spring tension and slot the pivot pin in, and then go to the other side and pop the screw and washer back in. And back to the electric screwdriver, and that's it. So we've got nice free movement of the hinge, and we will pop these hinge covers on. They only go one way round, so it's pretty straightforward. If they're broken, you can use a little drop of super glue on there. We have to do that quite regularly. Just going to pull that cable out. We're now plugging into the mains and switching on. That's good. Now we are just quickly checking for heat on both sides, which we've got. And what we do now is record the details of the repair, and then that will get transferred onto the computer. So in this case we've changed the cable, we've changed the socket, we've changed the 2 resistors. We'll just let these heat up, and then we've got a K-type thermocouple and meter, and we will just check the temperature. Now some pairs like this will just overshoot the target temperature of 186, and then over 20-30 seconds they will just cool back down to that. Others underachieve, if you want to put it that way, and then they'll just go back up to 186 after 30, 40, 50 seconds. In this case 186 is fine. Now we are going to plug into a separate socket. The irons are going to be left turned on, and we're plugging into the pat tester, and we're going to class 2 test them. Pat test is not a requirement for domestic equipment when it's being repaired. We do it just as an additional backup for safety reasons, and the fact that everybody offers a pat test. All the other repairers offer pat tests. Whether they do them, I've no idea. Pat test equipment is fairly expensive. It also has to be calibrated once a year. My pat tester is due to be calibrated at the end of this month, so that will be posted off in a couple of weeks for testing, and I will be back within a day or two. So in that case we are now done. We will go over to the other part of the bench, and these will be carefully wrapped up and posted back to the customer the same day that we receive them. So that is today's featured repair. It's the GHD model 4.2B, and this is a Type 2 version.